like I said, we will be calculating an information matrix, which is denoted by I of theta, where theta is the parameter that we have previously been estimating using MLE. So just to go back and review a little bit, L of theta, that will be our likelihood function, and little l of theta, that is our log likelihood function. Both can be found using MLE. So now we're going to get on to the actual definition of I of theta, our information matrix, and this is out of our textbook. So I of theta is defined as the negative expectation of the second derivative with respect to theta, our parameter, of the log likelihood function L of theta. So that's the actual definition of the information matrix. So let's try and unpack that a little bit for a one parameter distribution. So let's say we have a one parameter distribution where we have found the log likelihood function and our parameter is theta. Then the information matrix for our parameter theta, I of theta, would be the negative expectation of the second derivative of the log likelihoods function with respect to theta. So I'm just going to denote that as L double prime of theta. And for a one parameter distribution, this will just be a 1-by-1 matrix. So that's really not too hard to calculate. Once you the majority of the work will come in finding the log likelihood function, which we'll do a few examples of later. But once you find the log likelihood function, it's really as simple as taking a second derivative of that function. So for the second or two parameter distribution, it's a little bit more tedious because we have more parameters, but the thought is exactly the same. So for a two parameter distribution, which with, let's say, parameters theta 1 and theta 2, these are the parameters that we have been estimating, the information matrix would be given by I of theta, theta 1, and theta 2. And that would be set up by the negative expectation of L double prime of theta 1. So that's the second derivative of the log likelihood function with respect to theta 1. And L double prime theta 1 theta 2. So that is, the way you calculate that is first you take the derivative of the log likelihood function with respect to theta 1, and then you take the second derivative of the log likelihood function with respect to theta 2. The nice thing about that is once you calculate that, this part of the matrix, the third cell in the matrix, will be the same as the second cell. So it would be L double prime theta 2 theta 1. So these two entries are the same. And the last entry of our matrix will be L double prime of theta 2. And that is taking the second derivative of the log likelihood function with respect to theta 2. And so this matrix will be a 2-by-2 matrix because we have two parameters.